Hello, 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 hello. It is February 23rd, 2023, and we're here tonight to do some live coding, to hang out, to get to know each other, and generally just to enjoy what's the fact that we're here on this earth. So let's go ahead and do that. Hope you're doing well tonight. Let me get all my chats and stuff up. And let me know if you're in the chat, if you can hear me okay. Hey, yo, Big Samosa, welcome to the chat. You're the first one. Welcome. We are going to take a look at some coding, kaggling stuff. What do you guys think about that? Naomi, Haiti, Gabriel, everyone's in chat, hanging out. We got 3 people on Twitch. By the way, if you're not already watching on Twitch, please make sure you do that. Also, I will put the link in chat. That's where we hang out. Although YouTube's been showing up a lot more recently. What am I going to do? What am I going to do? Nothing I can do about it. I can't control you guys. I can just keep on doing what I do. All right, let me make sure I have my windows up and not listening to myself on repeat. And yeah, is this going to ask for my authenticator app token? I reset my cookies on my computer, and now I got to re-log into everything. Authenticator app. This is what I call two-factor authentication. Let's put that in. Remember this computer for 30 days? That sounds about right. Creator dashboard, that sounds about right. And let me show you guys what I'm looking at. Make sure I got this the right size. There we go, the infinite loop. There you guys are. That's our Twitch. And let me make sure I have YouTube up. YouTube. Look, someone's live on YouTube. That's us. Moderation activity is now hidden. I don't know what that means. All right, let's go ahead and get to it tonight. Here's the deal. On kaggle.com, there are competitive data science competitions. That's a little redundant to say competitive competitions, but let's go ahead and look at all of them. There were some new ones released that I honestly have not looked at. I've not looked at any of these, but I want to take a poll and see which ones you all might be interested in taking a look at. And then we could see what they're all about. What do you guys think? Let me make sure this is set up correctly. Yes. Hello from Donna, Texas. Donna, Texas. Where is Donna, Texas? Donna, Texas. Oh, right down there at the very bottom of Texas. That's where you're viewing from. Welcome to the chat. Thanks for hanging out all the way down here in the location of Donna, Texas. Let's go ahead and let's not ruin everything. I have my second screen is not here. Sorry, I'm just complaining today. It's a lot of complaining from me. I'm going to stop, I swear. What we are going to do now is there any spatial analysis? I don't think so. So here's the new ones that just launched. If you want to join the poll, I guess we'll call it, join us all over on Twitch. And I'm going to go ahead and start this Twitch poll. So let's get this over here. I'm going to go to this one. I'm going to start a poll. This is called pulling back the curtain. Clip that. No. Manage a poll. New poll. Which Kaggle competition should we look at? Okay, which one should we look at? Sign language? Maybe we should actually look at these a little bit before we make the decision, because I'm making you all decide. So sign language. Goal of this competition is to classify isolated American Sign Language signs. This seems really cool. You will create a TensorFlow light model trained on labeled... Wait, we will create a TensorFlow light model? Trained on labeled landmark data extracting Mediapipe holistic solution. Your work may improve the ability of Pop Sign Star to help relatives of deaf children learn basic signs and communicate better with loved ones. I mean, what's better than this? Seems like a great idea. Hey, J-Rod, thank you for subscribing, by the way. Spin the wheel for you. Spin the wheel for J-Rod. Thanks so much for subbing. What's it going to land on? Oh, no. Type pizza. Oh, so close to doing the push-ups. I really don't want to do the push-ups. So let's put this here. Let's type pizza 10 times. Can you hear it? See it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. That's for you. All right. So sign language is the first one we're going to look at, or the first option that you can vote on. AMP, Parkinson's disease progression prediction. Use protein and peptide. The goal of this competition is to predict MDS UPDR scores, which measure progressions in patients with Parkinson's disease. The Movement Disorder Society sponsored revision of the United States, that's a long acronym, is a comprehensive assessment of both motor and non-motor symptoms associated with Parkinson's. So let's see what the data looks like for this one. Data is only 59 megabytes. How is it so small? That's what she said. Who is that? Did someone just subscribe again? I can't figure out all my windows. Yes. Thank you for subscribing, S1LVRP. So this one is, we're going to spin the wheel for you. Man, I'm just all over the place. Can't get in a groove. What's it going to land on? No. Yes. Type pizza 10 more times. I swear it's not rigged. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 more for you. Thanks for subscribing. So the next one is this one's Parkinson's prediction. I'm surprised that this Parkinson's prediction one is so small. 59 megabytes, and it's only CSV, Pi, and SO. So the goal of this competition is to predict the course of Parkinson's disease using protein abundance data. The complete set of proteins involved in PD remains an open research question, and any proteins that have predicted value are likely worth investigating further. The core of this data set consists of protein abundance values derived from mass spectrometry readings of a cerebrospinal fluid. Samples gathered from several hundred patients. Each patient contributes several samples over the course of multiple years. Wow, this is a cool one too. Interesting. So this is just tabular data, I think. So we're going to have to learn about this if we choose that one. So that's number 2. Hello, everyone in chat, by the way. Silver, hi, Rob. Gonna seize. Yo, living that data science life on a Thursday night. Herbie Hoover knows what's up. Do you think that polars will take over pandas? Probably not completely. Or if it will, it'll be like a slow burn. But there are a lot of competitors to pandas. It's not just polars out there. Okay, so another competition that's out right now, and this could be an interesting one, although it's kind of every year. is the NCAA March Madness one. So March Madness doesn't start till next month. But they're, I think, just launching it, and I haven't looked at this yet. Is this evaluation is... Where's the metric? Oh, they changed the methodology. It's changed from prior editions of this competition. Submissions are now evaluated on the Breyer score between the predicted probabilities and the actual game outcomes. Breyer score, by the way, people, I know they spoke about this a lot in the book Super Forecasters, which I really liked. If you need a book that you're interested in, that you think would be fun to pass the time reading, check out the book Super Forecasters. But the Breyer score was used a lot in that. There are these professional forecasters who would use it. It's equivalent to mean squared error in this context. So they were using log loss for about 10 years or maybe longer. And now they've switched to the Breyer score. So that would be number 3. And then I think there's another one that launched that we could look at that is all competitions. We're going to skip over the Playground Series 1 and look at Stable Diffusion. So this is like a competition to do the opposite of Stable Diffusion. How are these so small too? Size is 3.24 megabytes. So we're going to have to dig into this. Why the data set is small for this too. Let's understand and agree those terms. Maybe they just provide a few images as examples. So I guess you can create unlimited data by creating your own Stable Diffusion predictions, and then you have to feed it back in. I know that I saw someone post on Twitter about this, about how they basically use Stable Diffusion to create an image. Then they use the image to create the prompt with their model, and they just went back and forth until it reached a steady state with some starting things. So they give it a prompt and they see how generic I guess I don't really understand how it worked. Okay, so that's the third one. So let's start this poll. Which Kaggle competition should we look at? Probably bad English. This is the poll on Twitch. If you are on Twitch right now, you can vote on this. If you're not on Twitch, you should join us. Here's the link. What do people want to look at? March Madness is in first place. We're going to learn about the Breyer score if we check that out. Sign language is now tied for first place. Look at this. This is so fun. And in the meantime, do you guys want to talk about anything else? Is there anything else going on in your lives? I hope Polars replaces Pandas. Seems more ergonomic to me, says Adrian. Cool. Yeah, people do like Polars. Whoa, Stable Diffusion is now coming out. Late to the party. Stable Diffusion. Stable Diffusion's really coming out there. And the sign language competition too. Look at this. There's such an even, diverse excitement for all the different Kaggle competitions out there. Look, I can't guarantee we're going to do well in these competitions, but I can guarantee that we're going to look at the data and we're going to try to figure something out. Life advice for a freshman software engineering major. Well, I didn't study software engineering in school, so I can't relate to you specifically. I went back to school afterwards to study data science, but it sounds like you're passionate about it. And if you're not, pick a major that you actually are passionate about. That's a mistake I made my freshman year, is I switched into something that I wasn't as passionate about because I thought it was like a better career choice. And then I ended up coming back to computer science, which is what I transferred out of my freshman year. So where you vote going to? Where's my vote going to? Feigl, what are you asking? This vote is on what we're going to do right now, what we're going to look at. So if it ended right now, Stable Diffusion would win. Pandas will never die, says Cho Core Latte. Yeah, I mean, it's like a staple of data science. It's never going to completely go away. All right, if we get a tie here, then I'm just going to make the judgment call on which one we'll do, but you can try to sway me in the chat by saying something. MMD is in the chat. MMD always going to bed whenever I'm streaming, always telling me he or she is about to go to bed. Never ends up doing it. What time is it in your time zone? 4 a.m.? 3 a.m.? Is the music too loud? Let's bring this down a little bit. Pandas will be incorporated for sure. Incorporated in what sense? Like bought by a corporation? I'm a guy. Okay, MMD. MMD is always about to go to bed. It's just what you do. So we see the time remaining because of this purple bar. So it was a 5-minute timer. But sign language competition has come out there strong. I think the sign language competition, not to get ahead of myself, I think the sign language recognition competition just launched today. Launched 10 hours ago. Hot off the presses. There's no way anyone knows anything more than me about it, except for the people who launched it. How are we doing here? Whoa! Sign language is taking a late jump ahead by 3 ahead of the Stable Diffusion. It looks like we are going to look at some sign language stuff tonight. The only downside of this, people, is that it just launched. Oh, and then it jumped up to 10 at the end. Someone didn't want to be part of the losing team, so they switched their vote. All right, we're going to look at the sign language competition. The only bad part about it just launching is there are probably not a lot of notebooks out there that I can steal from. So we're going to actually have to do some stuff ourselves and figure out. While you're waiting, could you please check if this correct ML process? I'm learning ML and ask a question on Stack Overflow. Yara, normally I don't do this. But I'll upvote this. Oh, I need to sign in because that whole thing. This is not a quick. This is like you're asking a lot of stuff here. You're reading data, train test split. I think you just need to read up on this. It looks like you're doing all the right stuff. It looks all right, but I'm not going to spend the whole stream looking at it. Sign language competition. Okay. Let's go here. Sign language competition. Here's the data set. Data set description. Deaf children are often born to hearing parents who do not know sign language. Your challenge is in this competition is to help identify signs made in processed videos. which will support the development of mobile apps to help teach patients sign language so they can communicate with deaf children. This competition requires submissions to be made in the form of TensorFlow Lite models. Google's coming in here on Kaggle and making sure that we only use TensorFlow models. No? Could you just take a TensorFlow Lite model and make it a wrapper around some PyTorch? I wonder if that's what people are going to do. You are welcome to train your model using the framework of your choice as long as you convert the model checkpoint in the TF Lite format prior to submission. Oh, so that's basically it. All the models are a bunch of floating point values and basically model weights in an architecture that is defined by the model, either in PyTorch or TensorFlow or some other thing. So what they're saying is you can train it on anything, but you basically have to convert it into TensorFlow Lite format in order to submit to this competition. I'm guessing because TensorFlow Lite then could be used in a mobile app because it's a Lite version. Please see the evaluation page for details. Everyone's using Parquet these days. We got Parquet files. That's the landmark data. Landmarks were extracted from raw videos with the Mediapipe holistic model. Not all of the frames necessarily had visible hands or hands that could be detected by the model. Landmark data should not be used to identify or re-identify an individual. Landmark data is not intended to enable any form of identity recognition or store any unique biometric identification. Okay, I wasn't thinking about doing that, but now I'm kind of thinking about doing it because he told me to. He told me not to, but I'm not going to. Don't worry, I obey the rules. Do you need to be good at math to do this testing? Probably a little good at math. Thank you. Just a question. Do you do EDA on full data or training data only, or it doesn't matter? You should, if you're creating your own data set, you shouldn't touch the test data at all. You should have that just off to the side. So you shouldn't explore that data, I guess. It's kind of hard to be objectively stratifying that out or whatever. The best is if your test data is something in the future you can actually validate on. Okay. So frame is the frame number of the raw video. Row ID is a unique identifier for the row. Type is the type of landmark. One of face, left hand, pose, or right hand. So they're using Mediapipe. I think what they're doing is basically taking Mediapipe and giving you Mediapipe's outputs run on a video so that you don't have to run that yourself, which makes sense. That's similar to a little competition I'm helping run right now for Kaggle in the NFL. We gave like the helmet boxes already from the model output. So if you don't want to have to create them yourself, you can just create some sort of model that sits on top of that. So look, Mediapipe can already identify in most cases all these different landmarks of a hand. So when detecting sign language, I don't know sign language. I don't mean to, I should learn some sign language, but it can detect your hand. And then if they've already run that on all these videos, they can grade it based on that. And you don't have to run the processing for it. I don't know if that's exactly what they're doing. What am I doing here? But it looks like they've done one for face, left hand, pose, and right hand. Now, it's a little strange that they have all these when I would think it's only going to be hands that we care about, but maybe there's another reason. And maybe the face landmarks is the reason why should not be used to identify an individual, because you could identify a person the hand. Landmark index. Landmark index number details the hand mark location can be found here. Okay, so then they actually linked, look, the same site that we jumped to. These are all the landmarks in the hand that they're, see, this is a hand that they're using, that they're going to provide us. XYZ is the normalized spatial coordinates of these landmarks. These are only columns that will be provided to your submitted model for inference. Okay, so we don't get any video. Let's accept this. This is cool. This is cool. So it's all Parquet, CSV, and JSON. We don't see any video, I don't think. Got it. Okay. This is a really cool competition. I think face is used in some signs. Oh, it is? Like, yeah. Like you're doing it close to your face. That makes sense. Okay, so let's finish through this. They're all in Parquet files, which is awesome. Train CSV, the path to the landmark file. The participant ID, unique identifier for the data contributor. Sequence ID is the unique identifier for the landmark sequence. And sign is the label for the landmark sequence. We're going to have to explore this in order to understand exactly what's going on. But we're trying to figure out sign language from XYZ points of hands like this. Or in some cases, faces. So we're going to be able to, this is going to be pretty cool once we do it. There's only 2 notebooks so far. So we're going to be the first one, really. Wait, we're not going to be the first one. We're going to be the third one. I don't know why I said we're going to be the first one. We're clearly the third. Hand emoji. Let's get a hand. Wait, what does this hand mean? Is that like okay? Let's copy this. Into here. Sign language recognition EDA. And then we're going to make... Ooh, it let me have that many characters. Usually it tells me that that's too many. All right, we're going to do this in a notebook. All right, so... sign language recognition challenge. The goal of this competition is to classify isolated American Sign Language signs. We are provided. So let's see what we're provided. Landmark data from raw videos with the Mediapipe holistic model. And are asked to predict the sign. From this data. Okay, so let's go ahead and do that. I see it. People are doing this in chat. What are you going to do today? We're going to check out this competition. Kaggle data. Draft session is starting. While the draft session is starting, let's go to our overview. Look at this video. We could watch this. This is cool. I would suggest watching this. I'm going to watch it afterwards. I'm going to put it in chat if you guys want to watch it. But what I want to look at while this is loading up is the evaluation. Where's my data tab here on the right? Did they change this? Oh, it's a little thing down here now. They made it just like an itsy bitsy thing down here on the bottom right. I found it though. This competition, you're submitting a TensorFlow Lite model file. The model must take one or more landmark frames as an input and return a float vector. So the thing about this is sign language can have motion, right? It can have motion to what you're saying. So you can't just take one moment in time and try to predict using that, or you could, but it's not going to be as good as if you have a time dimension to it. So that's why they're saying you must take one or more landmark frames as an input and return the float vector, the predicted probabilities of each sign class. Oh, so this is just a multi-class. So we're going to figure out what all the signs are we're trying to predict. The model must be packaged in a submission.zip file and compatible with TensorFlow Lite runtime. You're welcome to train your model using framework you want and convert it. Each video is loaded with the following function. Load relevant data subset. And this is a Parquet path. So it only reads in the X, Y, and Z columns of the path data. And we're going to do this. Evaluation. Inference is performed roughly as follows, ignoring details like how we manage multiple videos. That I'm not sure what they're talking about. Is this what it's going to look like? Interpreter.getSignatureList.keys. Model path interpreter. Required signature not found in found signatures. Raise kernel eval exception. Require input signatures not found. Oh, so we're just submitting the zip file of our submission.zip. It's going to read that zip file in and create an interpreter out of it. I don't know much about TensorFlow Lite interpreters. We're going to have to figure that out. And then honestly, I'm not quite sure what's going on here, because isn't it going to have to run on a Parquet file? Load relevant data. Prediction function. Get signature running, serving default. Okay, this is where it takes the input, which is the frames, which is the output of this load relevant data. I think, well, there's 2 months to try to figure this out. Oh, by the way, first prize is $50K. That's no joke. And then less than 9 hours to run. Okay, so we're going to have to figure this out, and maybe the other notebook will give us an example too of how it's run, but they didn't even tell us what the evaluation metric is. The evaluation for this contest is a simple, classification accuracy. So that we'll put here. Data EDA. Let's read this CSV. Should I use pathlib? So our base directory is going to be this input ASL signs, train, no, that's just this. Baster, train.csv. So this is our training CSV. Let's see what shape this is. 94,000 training examples. Train.csv has the path to each parquet file, the participant ID, sequence ID, and sign. What signs are we trying to predict? What are we even trying to predict? So here's the signs. We can value counts on this. It's kind of big, so there's 250 unique signs. Ranging from 299 to 415 examples of each. But how many overlap? This I don't know. So we're going to plot the top 20. Let's import Seaborn and use a Seaborn colorblind. Let's also is the internet on? Accelerator, no. Internet is on. Oh, it's on by default. So we're going to load NB Black. This will make our code nice. What do you mean by overlap? How fast is Kaggle compiler? Kaggle's online free kernels / notebooks. Things have changed around since I've used it last, but they're okay. They're like decent sized machines with potentially big-ish GPUs. Oh, this is what I'm looking to click on. Yeah, so this is, you can see it has 73 gigs of space, of disk space on this. I'm not sure how many CPUs it has. 30 gigs of RAM. They upped that. And then we don't have a GPU selected, but we could potentially have a GPU. Why isn't this working? Oh yeah, load extension lab black. That's what I want to do. And pip install silent. -- quiet. I should put that here. Install NB Black for auto formatting. That's what we're doing here. And then we're going to also go down here and actually load it in on the same cell as where we install it. And we have our train data set. So we're going to do a 10 by 8, and let's do the top 50. Title equals top 50 signs. All right, this is why we installed MB Black, because when I run this cell now, it's going to auto split these lines for us. Sort values ascending equals true, maybe? Yeah, this will give us the top 50 signs. So we can see here that the top sign is the word, or is the sign for listen. That's exactly why they have the face, right? So you can do the hand relative to the face. And then let's do the bottom. Bottom 50 signs. Might as well just do them all. Zipper. Zipper is like the least one. Vacuum. Beside, person, dance. Man, I wish dance was a little bit higher. What's MB Black for? It's for auto formatting. It runs the black formatter on your code when you run the cell. Let me make sure I say that this is in the training data set. Is it just me, or is this kind of like too big? I made this too big. And this should be... should do it like this, and then provide this the axis that we'll plot on. And what else? We'll set the X label to be number of training examples. Right? Let's just copy this. Bottom, and we'll do a tail here. All right, let's load an example of a file. So let's load one of the, load listen, since listen is such a important one. Let's query where sign equals listen. Now, one thing I did want to see is, are all of these is there gonna be overlapping paths that also have listen? Okay, so the question I'm trying to ask here is, is there only one sign per Parquet file? So let's do train path value counts on this. So we'll answer our question. Yeah, so every Parquet file only has one sign associated with it. But what is the rest of this data? Is the sequence ID. Oh, so the path is participant ID sequence ID. I see now why it's formatted like that. And that's exactly why it's this. Okay, so let me undo that. Each Parquet file is in the path let's find this exact path to the file. Each So now we know the path of the parquet file. The parquet's associated sign can be found in train.csv. So we're going to search here. Query sign equals listen again. There we go. And we're going to pull one of these. So we're going to pull an example parquet file data. We'll do that here by doing values and pulling the first one. And then we'll, what is this parquet data called? Example landmark. pd.read parquet example file name. No such file or directory. Oh, that's because it has to be. Let's list all the data here. Wow, LS is really struggling here. No version information available required by. I don't like this bash command. All right, so now we can see in this folder, and this G flash lets this be colorful and gives us the backslash so we know this is a file. So it needs to be on top of the base directory. So we need to find this base directory, basically. Base dir, and then plus the example file name, and this should work. Example landmark. So this is the landmark. We pull an example landmark file for the sign listen. Let's look at these landmark. Let's look at this landmark. So what do we have? All right, so there's 543 frames. No, wait, sorry. There are... So the file has 6 unique frames. Let's loop over. Let's also find how many unique landmark types that we have. Should you check for possible data leakage? I'm just going to trust that they've done a good job with that so far. They also said not to identify personal identifiers from it. Like try to identify the person from the from these landmarks. Rob, what time zone is my location? I am Eastern Standard. By the way, sorry if I'm late in responding to the chat. I've been getting into this competition because it's so exciting. What's the best compiler for data science? Is that Kaggle? Kaggle's not really a compiler. So we write most of our code in Python, which isn't a compiled language. Hi, Rob. I'm so happy to watch you live. I'm a great fan from France. Joel. Thank you. I hope I'm pronouncing that French enough for you. Sorry, what are you doing? What is this for? This is a Kaggle competition. Hard Roko. We're looking at a Kaggle competition. Rob, how are you getting those autocomplete options as you type? Is that built into Kaggle Notebook? Yeah, that's something that's built into Jupyter. It's tab completion. It's pretty good about it. Oh, and I screwed up my chat. This chat thing from Restream hates me. So we're going to do that. All right, unique type. All right, 6 unique frames and 4 unique types. And then we'll just do the types in videos will be example, landmark, type, unique. And we'll just print those. It's cool to have a video competition with no video. New one. Okay, so it has 4 unique types: face, left hand, pose, right hand. Let's compare for the different for a bunch of Parquet files what type of data we have. So let's go like this. Let's go like this. Let's do so this is going to give us all a bunch of paths for listen files. For F in listen files. And let's do enumerate over this. Then we'll do our read in. And then we'll do our print. And if I equals 20, we'll break out of this. So let's see how quickly it can. Oh, it can run through this quick. All right. So one thing that we're finding is that the duration of these is not consistent. Look at that. So I have an idea. Let's create some metadata for the training data set. So we have this. Might not want to run it on everything right now. We have 94,000 rows. And that means 94,000 Parquet files. We're going to import TQDM up here. Hey, thanks, Burstly. Appreciate that. How fast is Kaggle compiler? This isn't a compiler. It's a virtual machine. We notice the number of frames is not consistent. Almost every file has 4 types of landmarks: face, left hand, pose, and right hand. At least for these examples. But we're going to do iteros, one of the One of the rare times we want to actually do iteros. And then we'll do the total of this TQDM will be equals the length of train. There we go. So this will loop through it, and then we'll take this D and we will read in the Parquet file. I should really call this path. I don't know. Like this. File path. Let's be really descriptive with our names so it's clear what we're doing. We're pulling in the file path, and then we're getting an example landmark Parquet file. This is cool. Okay, so example landmark. Then let's make this into some metadata. So this is the metadata for this file, which is the face, the pose, right hand, and then we'll also take this frame and unique. This will be frames. Be equal to this. That's the number of frames. What else do we want to get from this? Example landmark. Landmark index. Well, the landmark index really depends on if the face is involved. Yeah, so we're going to be able to we should be able to plot this out. Hello, Sir Robert Mullah, sir. Thanks for start live. I'm your big fan from Bangladesh. Nice. Welcome from Bangladesh. Hi again from Ukraine. Great video. Have you have to go to work, and we hope no 2-day big rocket assault. Man, stay safe. Thanks for hanging out from Ukraine. That's awesome to have you in the chat. All right, so the metadata, meta. Now we have this. Is there anything else we want to pull from this? Okay, so the row ID is the frame, the type, and the landmark index. This looks similar to how I did it with some other stuff. Can I do ag x min max? It's not like this stuff really matters. Y min max and then z min max. Hey, dope content. Thank you, Zishan. Thank you. Appreciate it. Appreciate it. You don't need to donate, but that's nice of you. Gonna put it all back into the channel in some way, shape, or form. I plan on. So how do we add this dictionary to this dictionary? So this is like our XYZ metadata. Min, max, and mean. It's like our XYZ metadata. Now I know we could do dictionary comprehension in Python. I learned about this from a YouTube video, I want to say, recently. So dictionary from keys range, we can do. Dictionary comprehension like this. No, I want to rename the keys. How did you bootify that cell? NB Black. I will send this to right your way in the chat so you can check it out. I believe the idea is to help create a model that will then be used by apps that would help someone learn sign language. Correct. Yes, this is a Kaggle competition. Let's save this version and see if I can share it with you guys while it's going. Any other questions? Rob, do you still work or are you done working or just do YouTube now? Oh no, I work. I work mostly. YouTube is just a fun side hobby. This is just for fun, guys. I'm not doing this for the $5 donations, although I do appreciate it. Hi, Rob. Do you keep these stream cods anywhere? Sorry, I meant to ask you this so frequently. They're all in my page. So here's my YouTube page. You go on live. I leave them all up here. So you can see my last one's here. I was too lazy to put a thumbnail on this one. And this is us live right now. We got 50 people watching. Nice. But this will stay up here. I'll try to add a thumbnail to it later and maybe crop out the beginning. And then probably get dinged for copyright infringement because of the music that I'm playing. Even though it says it's a copyright-free playlist. Sorry, didn't mean to get angry there. Can I do this to rename the keys? So hacky. So for each key in this XYZ meta keys, I am going to create this new key, which I will then append to our meta dictionary. Yeah, this new key will get the XYZ metadata for this key. X not defined. Oh yeah, because that's this key and then another key, right? Yes. Now let's look at this all together. Yes, this is my hacky way of adding this stuff to the key. So let's see what it looks like. The metadata for this file is this. And now let's do this. Let's do combined meta is just going to be a dictionary where we take in, what is I? I is the index. We'll take in the file path meta. No, wait, not meta. Combined meta for the file path. And then we will add this data into it. If I It's greater than or equal to 50 will break. So we're going to try to run this on 50. So quick. I mean, to run all 94,000, this would only take an hour. We don't want to waste an hour here, but now we have our combined metadata about these files. So let's create this into a data frame. That's not what we want. Oh, it kind of is. We just need to transform this. So now we have for each of these files, the number of rows that are for face, number of rows that are for pose, left hand, right hand, frame, the number of frames, X-min. Yeah, these values, I don't know how helpful they're going to be. But let's just run this on, should we be dangerous? That only took 1 second, so let's do 10,000. No, 10,000 would take too long. 1,000. 1,000. Yeah, it's not going to take that long. Would resetting the index do anything? Yeah, that would be a good idea after we're done with this. What I want to do is merge this back onto the training data frame, actually. There's got to be a better way. I think there's a better way than doing this transpose after I load this in, but you're right. So resetting this index, and then we'll rename columns of index to be named, what is it called on the training data set? To be named path. And then we'll use that to merge onto our training data set. And we'll do how equals left. And we'll run this. Now we have training data with metadata. We only ran it for first 1,000 of these 94,000 because we don't want to sit here and wait. But I could run this later with all of it. While this is going, failed after 0 seconds. Why did this fail? Where did it fail? Oh. It's funny that it failed on their example code. Below code was taken from the evaluation page. So let's try to save this version again. I'm going to go here into the settings of this code and make it public. Where's the save button? Here it is. Save changes. Let's go to this notebook. Can anyone in chat let me know if you could see this notebook? Give it an upvote so I know for sure. Toggle this up vote. All right, so do you guys understand what this is? Does doing these kaggle competitions and always learning new things make your life at work any easier, like facing challenges or daily tasks? Yeah. They do. Also helps you think about the problem in like a skeptical way, because when you're doing kaggle competitions, you're kind of testing the limitation of what's possible, and it gives you a really good idea of what is not possible when it's brought up, or what's not known to be possible yet. Nope. So you're saying you don't see it? Says actively running. Okay, so you guys uploaded it, but okay, now refresh your browsers and tell me if you see it now. I should promote myself. This notebook was created live during a live coding stream. Watch it on my YouTube and Twitch page. YouTube is going to be, how do we do URL links? We do this. How do I do the subscribe confirmation? This is something I learned. This little hacky trick. If you do !sub confirmation equals 1 to the URL link, then when people click it, oh wait, it doesn't work. Maybe because it has this equal sign. They click it and then it automatically will pop up for them. Do you want to subscribe? And then when I do it, it says you can't subscribe to yourself, you idiot. But that's the idea there. Put this here. Good morning, Fakey. Very sneaky, LOL. Yeah, I learned that from someone else's links. Little trick. You learned it here first, folks. You learned it here first. I'm having a lot of fun with this competition. We haven't even looked at the data yet. We haven't really looked at the data yet. Are you guys having fun? Put an F in chat if you're having fun. F is for fun, folks. GF. All right, so we're going to look at these columns in the metadata to try to get an idea of what are the most frequent types of landmarks provided. We could just sum this. I need to put this in here. Sum of rows by landmark type. So mostly face. That's because the face, Mediapipe face mesh. So that's because face mesh has a lot of data points. So it's going to be biased in that sense. Like, look how many data points there are. Information about the face model is in this paper. Man, it's cool that this is a cool designed competition. Like we don't have to deal with video files. But that's why we have mostly face. What if we do train meta? And then we do this. And we do max. No, not max. greater than 0. Drop NA subset equals face. This is going to drop all the columns that we don't have. And then we're going to do the mean value of this. I know this looks weird and it's not interesting. So this is just saying in the face, pose, left hand, and right hand are in 100% of these 1,000 videos that we pulled. Every Parquet file has at least some data points for face for all 4 types of stuff. Types of landmarks. Face, pose, left hand, and right hand. Face has a lot more data points because Mediapipe provides how many landmarks in Mediapipe face mesh. I want to find this 468 3D data points per frame. I guess if it can find the whole face. We're going to run this code on it in a second here. Check out one example. Oh, one other thing we want to do. And I'm going to change this to run on more than just 1,000. So let's make this like n parquets to read. So we don't have to load all 99K. Come on. 95K. Check out one example and let's plot it. So let's load our example landmark like this again. We're gonna do a listen one. What's the average frame? Okay, so like let's query where the frame equals 38. Middle of the video. Oh, I just realized something. X, Y, and Z values can be null. What's the context of the greater than 0? So this is checking to see if the number of landmarks for this type is 0. So what I'm realizing is that I didn't realize before is that these values can be null. So before, when I was creating that metadata, I was just taking example landmark and I'm doing type value counts and it assuming that we have values for each of these. But I should do drop NA subset like X, Y, and Z. That gives us the actual amount that we have. So what happens is, yeah, so this plot is wrong because They provide a row for everything, even if it doesn't exist. Then they provide null values. You guys following me there? You got to trust me here. So we're going to rerun on these 1000. Get the number of landmarks with XYZ locations data per type. Super fun competition already. With the subset. What's the subset? Did I do a subset too? Yeah, so this drop NA subset is just because we ran only on 1000 of the Parquet files. So otherwise this average would be messed up. I'm not doing a great job explaining this. The break condition is wrong. You're right. Thank you. I would have sat there for like 2 hours without, if you hadn't said something. Maybe we should just do some Mediapipe stuff to show how it works, but we should probably plot this data first. All right, so it ran 1000. We're merging it on. Now we're going to plot. Still, we have the most of face. But here's the real question. Yes. Hold on a second. Now these values are null. Interesting. So I need to do this. Query index is less than 1000. Because this drop NA is not going to do work. And then we'll do fill NA with zeros. I don't believe this. I must have done something wrong. So we're saying that the face, there's always something for the face. So here we're in the middle of the video, and yeah, there is stuff for the face. So the face is always there. Title here is the percent of examples, percent of frames with data. Percent of frame slash key points with data. So we always have 100%. I guess it's a rate because it's not a percent. Right hand more than left hand, but these are about 50-ish% of the time that they exist. Otherwise, we don't have the key point data for them. Heck yes, data science, Johnny. You know what's up. You know what's up. All right, so we want to take our train with meta example. And we want to drop an A subset of, let's just drop an A. This will drop any examples where we don't have all three: face, pose, right hand, and left hand, which happens to be way over here. So we're going to subset to that. That's going to be our example. All right, so none of them have listen. What's another popular word up here? Or sign? Look. Look. Look, listen. All right, we know. Ooh, shush should be a good one. All right, so this frame median is 25. So this is giving us the middle of this example. And let's try to plot. All right, 3D plotly, 3D plot. So we're going to do a 3D plot. Of landmarks from example. And we're going to do import plotly express as px. Import plotly express as px. Px line 3D. No, not. We want a 3D scatter plot. Scatter 3D. Our data is going to be this example frame. That's a single frame. Come on, auto shift tab used to show me the doc string. They've changed it. Why have they changed it? X, Y, and Z is going to be all right, so this is going to be pretty simple. Data is example frame. X is going to be X, Y is Y, and Z is Z. We're going to color by it. Is it called color what we call it out? Color is by the type. Hopefully this looks cool. What in the world? So this is the person's face, apparently. Maybe they're not in the same. Let me take this dark thing off. Let's turn on face. All right, there's the person's face. Do you see it? Do you see their face? Some sign's not going to have every column. What do you mean by that, 5-shot? Don't you need to have data for each column? Not sure what that means. So this is someone's face. There's their face. But why don't we see the hand? Maybe because yeah, there is no right hand. But I thought we picked one that dropped NA. Right? Did we run this? It could be that frame. So group by frame. X is NA. No XYZ is going to be this. And we're going to group by the frame. No XYZ is sum. So this means that frame, okay, so this is what's going on. At frame 19 and 17, so this is the number of missing values per frame. And it looks like 17 and 19. Pick frame 17 because we have no missing XYZ data. All right, so let's go here, delete this, and do 17. There we go. It's this 3D space is kind of weird. I wonder if we could like orient this in a way that makes a little bit more sense. But let's try to just show the left hand. It's going to be hard. It's going to be hard to plot this. Are they relative? Let's see, left hand to right hand. Right hand, left hand. They're over each other. They're over each other. All right, so where's my music? Where's my music at? Man, I wish I could work on this one for like days on days. Are you guys having fun? Hey, Rob, if you can do a session for data analysis using PySpark data frame. I have a YouTube video about that, but no specific session yet. That's a good idea. Let's save this version. Let's also save. What I'm going to do at the end of the night is I'm going to take train with meta and I'm going to say to Parquet train with meta.parquet. At the end of the night, to be super crazy, I'm going to remove this or make this end parquets to read larger, and then I'll just run this notebook. And then we'll have that data as the output after an hour of it running. That's what we should have. So this is kind of hard to see. What I want to see is with Mediapipe. Plot landmarks. And has someone already done this? They just went straight to training a model. I don't know what this is. This isn't the data set that we... Okay, so they read in the new Parquet file. Then what is this? Sign to prediction index map. Okay, so they're just encoding them to numeric values. Then they're reading in sign language MNIST. Yeah, this is just going to confuse people. Probably a tutorial they took from something else. Right? Might be missing it, but this isn't the data we're given in this competition. It's just another MNIST hand data set. So let's go look at other people's stuff. Read one Parquet file. They're using Dask data frames. Okay, they're small files, so using Dask might not be necessary. What we want to do is actually plot these using Mediapipe. They said they used holistic. What did they use to create this data? These notebooks, we're just a few hours in, so not that many notebooks to look at. Look at this overview data. Oh, okay, so I was missing this. That's what he was pulling in here. This makes sense now, that these are mapped to numeric values. Sequence ID, XYZ. Hand landmark locations can be found here, but we want all the landmarks. Mediapipe holistic model. So it's this one. So this is how we draw with Mediapipe holistic for static images. The 3D plot is kind of hard to see. Try to use Mediapipe to plot. So this is actually using Mediapipe holistic model to read in a file. Reading a bunch of files, actually. Print the coordinates. And then this is what we want to do. Is draw on this XYZ coordinate, right? I think that's what we want to do. So let's try to do this on an image. Let's try to do this on a whole person example, like they show here. Holistic. Why do I keep on putting W in for holistic? Yeah, where's this guy? Mediapipe holistic guy. I want that image. I want this guy. Let's try to do this. This image. Maybe like this. All right, this image. Let's see if we can run it on. Weird search query, but okay. I was just trying to get my hands. All right, so we'll get this. Pull an example image. Run Mediapipe holistic to see how it produces the results. Plot them on the image. So this is pretty easy because image files is going to be this image. No module named Mediapipe. Seriously? We're going to have to load Mediapipe quietly. Shush. Hello, I'm new to DS. Excited to learn new things. You're in the right place, King Kid. King Cold. Exclamation point YouTube. We'll take you to my YouTube channel. Or youtube.com. LOL Panda Spark. Yeah. Shoot. I don't know if it installed so correctly, but let's try it. That's the pose estimation? No, 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 no. How is that the pose estimation of this? Image files. There I am. Drawing landmarks, pose, face mesh. So let's see what the face mesh landmarks look like for this. I'm basically trying to hack it so I can see what the landmarks look like. So then I can put the data from this into that format to try to view it. But why is it not showing the beautiful plot of the nose coordinates? Let's pick a better image. How about that? Our Y and Z, I think it's just getting messed up because there's not a full person in the picture. Person for pose estimation. Example, single person. So I don't want the pose estimation to be drawn on them already. Person standing basketball? No. Person standing. Here we go. It's all watermarked. But we're going to not do my picture anymore. Instead, do this person's picture. Full length, fashionable young man standing on isolated white background. Now that's a detailed name. Whew. Maybe I need a... I am read this image. And show this. There we go. There we go. This is what we were trying to show. So this is the isolated image of this person. Let's also, let's get mine now. I wanna, Rob Mulla hands. Hands. There we go. We got hands in this. No, I don't want that. I want the... So now we have two images we'll process. This HQ default and this full-length portrait of a fashionable young man standing on an isolated white background. I don't know why it plots this. This throws me off. All right, so now we'll do ls in our temp directory. Oh, this is annotated image star will be, yeah, so we have 0 and 1. So we'll do 0 and 1. Look, it got my thing, but it didn't get my hand. What the? It cut out my hand. I'm wearing the same t-shirt. But now we get an idea of what this looks like. Now let's reverse engineer to try to, I don't know if this is going against their rules about not trying to personally identify someone. I hope it's not against the rules. Try to use the same format for plotting on new of parquet data. So clearly we won't have this background image, like the person's face, but we could try to plot with these colors and stuff what the hand looks like. So I wonder what the size, okay, so this is where our media, let's try to get the bounds train with meta x min x max just trying to get an idea of the image size that we want to make. So the annotated image is just an array of shape like this. So let's make background image as numpy zeros like this shape. Background image. So if we zeros like this. Oh, just zeros, I think. Yeah, now we have, this is a NumPy array of 3000 by 825. This is the dimensions of the thing. Are you guys following me? Is this fun? Someone say something in chat. I'm having fun. So this is just going to show like a black image that's not very cool. Because it's just... I'm guessing the videos are like 720p or something, but we're going to try to do this. Zeros. Something. Okay, someone said something. Thank you. So now we're going to try to take these. What we have to do is, what should we start with? The face, hands, or the pose? Let's start with the pose. You stepped away for a second. Now you're lost. You'll catch up. You'll catch up. I hope so. We basically ran Mediapipe's holistic model on 2 example images. Me, one of my YouTube thumbnails, and then also on a full-length portrait of a fashionable young man standing in an isolated white background. We ran this on both of those, and then I showed what the results look like. I want to make, so we're not going to have the background for this, but I want to make this type of image for our example frame. So our example frame looks like this. We have face and then the landmark index. But what does the Mediapipe data expect to see? Maybe we'll try the face landmarks first. So we're going to want to take it. This takes in the background image or the animated image, and then the results.face landmarks is the main thing that we're going to want to grab from. What type is this? Normalized landmark list. We want to build a normalized landmark list. So I think I might be able to do it like this. All right, so this will create a normalized landmark list. But it's going to be empty. So what if we just give it the example frame? What do these landmarks look like? X, Y, and Z. So we have to populate this with a results, a landmark. So what is... landmark will give us X, Y, and Z values. .x. Ooh, so we need to make a normalized landmark? Jeez. Hey, Kaiten, what's up? Jigaman, sorry to hear that. What's wrong? On my interview today, so yeah, that happened. Oh, sorry, Jigaman. That's a bummer. Bummer. You know what? Whatever doesn't kill us makes us stronger. You're going to learn from this. You're going to learn. So basically, I want to query where type equals face. Lowercase f. So this is our XYZ. I don't think I can do like this normalized landmark list. If I just give it this, no positional arguments allowed. How to create a normalized landmark list. To access the iterable landmarks, you need to do the following. Are you using Hugging Face / Transformers? No, I'm not. We're using Mediapipe. So what is this person doing? They're taking it and they're plotting them using, okay, so this could be cool. They're only taking X and Y and they're plotting it on their hand. So that does work. In that case, we could just do, wait, in that case, we could just do example frame, plot X equals X and Y equals Y, not plots. Style is a dot. Yeah, but we don't have all the points connected like they would if it was Mediapipe. So what we need to do is figure out how to make a normalized landmark list. We want to search GitHub for a normalized landmark list. Oh, it's going to make me do two-factor. This is built in Java. So I don't know if I can create a normalized landmark list. Let's see if I can show this background image. There's a face. That's this guy's face. So I want to get the results.face landmarks. I want to get this type of image. Yeah, that's not going to look good. For the, yeah, neat face is right. I want to get this for the stuff. Is this doing hands too? Looks like it has some hands. We want this to be background image. There, so we could see the person there. But do we see the hands? I don't think I see the hands. Guys, this is too fun, but I gotta end it here. I think we gotta end it here. This is a good part to stop on. To do. Figure out how to transform the Parquet file data into Mediapipe. Normalized landmark list. That's a definite to do. How do we make wget silent? We do -- quiet. We want these to be quiet. Let's also install Mediapipe on the same line. clean this up a little bit. And see if I can save this version. If this runs all the way through, we're in good. Draw the result in the image, use draw landmarks. The function drawing utils class has a note that we already installed our drawing utils class at the beginning. Where are you getting that from? What are you listening to? I'm listening to a supposedly copyright-free playlist. Hopefully I don't get hit for using copyright stuff. My video takedown. All right, what did we do today? We looked at this sign language. We did a first look at Google's isolated sign language recognition competition. We looked at the data. We understand the metadata. We understand that we're trying to predict what class of sign is being made out of how many example classes are there? 250 unique signs. We figured out that you can pull in basically in 3D these data points, which are kind of hard to make out from this. I know if we zoom in at the right angle, might be able to see. You know, I think we should just try plotting it in 2D. Scatter 2D. The Z-axis might be what's screwing us up. Oh. And they flipped it upside down. So Y. Let's flip Y upside down. Every time I think I'm done, it just pulls me back in. They might not like that I'm showing the face. That's the face. Left hand. It's hard to make out the hands because we need to draw the lines between these. We basically need like we need to know the connection map between these. There's got to be like a map model out there, like a rig. Hand landmarks. MP hands that hand connections. Maybe this is what we want. What is the hand connections? Mediapipe's hand connections. This is a frozen set of the connection between each. So I could draw a line between each. Right? Let's try to do this. Let's try to do this. So a frozen set, we're going to take example landmark for the left hand. And then we're going to make a matplotlib plot. And we're going to make a scatter of the example left hand X and Y. So these are all the points. And then we're going to say for connection in these hand connections, then we're going to plot those connections. So the connection is going to be point A and point B. So we're going to draw a line. Draw a line from XY chords. Import turtle. Plot. So it'll be like this. X1, Y1 is going to be example left hand. And we're going to query landmark index equals point A. All right, so then we're going to take X and Y underscore. I'm assuming that's. Then we have the values to list. X1 and Y1 is going to be this. Yes. X2, Y2 is going to be this with point B. And then we're going to plot a line from these two different points. There. So that line doesn't make much sense here. But once we put up in here, it is. And then we're going to say color equals purple. I don't know if that'll work. Okay, so the problem here is that we need this to be Y underscore. There we go. There's our hand. It kind of looks like this. What is this? Wait, so we can also kind of, because we have this rig, hand rig, we can tell what point is the thumb and all that stuff. Did this save version break? No, this ran. Okay, good. Oh, it did break. Example frame is not defined. Got to define this first. Let's try to save this version. You know what would be cool? Let's try this. As a thumbnail to my video, I'm going to go like this. Can I screenshot this? Screenshot. No, I need to be out of here. Hold on, let's move this chat out of the way. All right, hopefully that wasn't too painful. Let's save this to our desktop, move you guys back in here. All right, what I did was I took a screenshot. This is me. Let's open with another application and crop this out. Let's crop. Oh no, it looks kind of crappy. Crop to selection. Maybe I'll do this again tomorrow. Crop to selection. Save. Look how crazy I look. I look crazy in this. Save this. It's on my desktop. So maybe I need a conda activate Mediapipe, pip install upgrade Mediapipe. All right, Jupyter Lab locally. Conda deactivate, conda activate. Kaggle 2023, Jupyter. Open my desktop and Jupyter Lab on this. Try to Mediapipe on this. On my image. And let's choose Mediapipe. Let's see if this one ran. Failed. Failed after how long? Where did this one fail? I'm a failure. Oh, it's the same thing. Save this version. Why are you crying? Prime, why are you crying? In chat. Because I'm a failure? It's okay. I've gotten used to it. All right, so we'll just run this code. But make my image name. It's called with hand. Rob with hand. Rob with hand. .png. Delete this one. I don't like that it does this. Background, it removes the background, so I'm going to undo that. And then I'm going to write out annotated image here. All right, did it write it here? All right, here it is, annotated image. The hand is not that great. Seems like that I'm catching the tail end of the stream and watching your YouTube for the past couple of weeks. Nice. I'm really enjoying them. Thank you. Appreciate that. I'm just trying to get a decent picture. Now you guys can see what I'm doing after the stream usually. Trying to make a dumb thumbnail. Dumb thumbnail. I'm gonna open this. Zoom in here. I look a little less stupid in this. Maybe looking stupid is a better approach for this. Crop to selection. Save this as Rob2. Process Rob2. Hopefully it'll get my hand a little bit better this time. Nope. Still pretty bad. I think it's because it can't get my whole hand very well. Hey, what just happened in the background there? Mr. Gabriel Blintz, thank you very much for subscribing. Oh, I forgot you guys can't see what I'm doing on my screen when I do this. Let's go ahead and spin the wheel for you. And then let's end. I'll make this thumbnail offline. How about that? No one wants to see this. No one wants to see any of this. Yes! Gabriel, thank you so much for subscribing on Twitch. No Kevin tonight. You got to earn it. All right, let's check and see if this notebook did actually run through. No, it did run with an error. What failed in 6? Version 6. Oh, it got this far at least. MP is not defined. I thought we did define. I guess I hadn't. And I also need to install it here. Import Mediapipe as MP. I kind of want to do this left hand and right hand. Keep on getting sucked back into this. So this will be for the type equals hand, hand, finger, thumb. And this is now no longer just the left hand. Example hand. We'll do a scatter plot here. That's the two hands going shush. That's going shush. That does look like shush. That's the shush hands data. All right, hopefully this will run through now. We did a lot tonight. Look at what we did. We explored the data. We pulled in the Parquet files and explored those. We made the plots of the hand, plots of the other stuff, and then we ran Mediapipe so we could see how it runs if we ran it on a single image for ourselves. All that good stuff, and now it's time to go to bed. So thank you all for hanging out. Let me know in chat. Very unlucky for what? Oh, for it to land on do nothing. I appreciate you all hanging out with me. Hope you enjoyed this stream. I will see you next time. I'm going to be out for a while. I'm going to be traveling for work, so I'm not going to be streaming probably for a week. So I won't see you guys until like a week from next Sunday. Tell your friends. Don't be waiting up for me late at night because I'm not going to be around a while. All right, I'm going to just go ahead and end recording now and end the stream. Oh yeah, pull this back in. And I will see you guys next time. So check out my channel for more videos and stuff. Share with your friends. Exclamation, or let's go to youtube.com/@RobMullah. We have the Twitch stream. We have our Discord, which you can join if you want to chat. Twitter, Rob_Mullah. Let's make sure that's the right one. Just giving you guys a whole bunch of links here to go ahead and follow me on. All right, I'll see you next time. Thanks, everyone. Have a good one. Be kind to each other, and let's keep on doing data science stuff.